Hello, and welcome back to another episode of Crypto. Oh my God, it's Friday. The market's not doing so great. There's a lot of concerns around tariffs and broader market structures, and of course, crypto's being hit and taking the plunge on the way down. Don't blame me. I didn't do it, but I don't think we're coming out of the pain cave for a little while. We're probably going to see downward trends before we find a floor. So with that being said, let's look at some of the technology coming out these days, eh? I'm going to open up and discuss a large chunk of tech that was actually released this week called Walrus. It's one of the more utilitarian sectors of the space, so it is something I like to focus on. When people say, what is crypto really used for? It's just scams and exit liquidity. I mean, decentralized file storage is a great place to point at. So our story starts with Sui. Years ago, a small company called Facebook, you might know them now, Meta, decided to come out with their own blockchain. They were going to begin to move money inside the Facebook platform. They came up with this amazing programming language called Move under a brand name called Libra. However, the regulators got wind of this and they did everything they could to halt this product in its tracks. So from there, Facebook ended up giving up Libra, just kind of coming to the conclusion that it was going to be an endless battle. And the Libra company split into two different entities. One is called Sui, which is actually the original developers and the lead engineers. And another was sort of the marketing team moving onto what is called Aptos. Both of them are leveraging the Move language. So Sui here is run by Evan Chang, the head of the Libra code development, and they've done a really great job. It's just a simply fast chain. I don't know how to express it any more than that. That's its fundamental offering. It is super fast and super easy to build with. Now, it all really does come down to this Move programming language. Now, a lot of the exploits that happen in Ethereum are because the Solidity programming language is pretty tough to work with. It's very easy to make a flaw, requires many audits, and a lot of the exploits were actually just taking advantage of the logic structures, right? So not even saying hacking the code itself, just seeing how it was flawed and where those sort of openings could be pitted against. So just to open up, and this is coming from Halborn, smart contract platforms like Ethereum and Solana are designed to allow developers to write programs to run on top of blockchain. These platforms have their own virtual machines, VMs. You may have heard of EVM or SVM, so Ethereum virtual machine, Solana virtual machine, and that's where the code is executed. Now, what's important, Move is a programming language developed by Meta for the Libra DM stablecoin. One important note to take away, Meta really wanted to apply this across their product suite, right? We have WhatsApp, Facebook Messenger, Instagram, right? This was a stablecoin product that was going to be embedded across these very highly scaled apps. And for that, they needed something that just the current blockchain status could not do. You just can't scale Ethereum that fast, as we saw with the CryptoKitties NFT drop back in 2017. Like, Ethereum has a propensity to get slammed when there's just too much transaction data. This causes gas to go up. It gets very expensive. That's the way the Ethereum bottleneck manages itself. It just prices out any transaction that doesn't want to pay that cost. However, for a stablecoin, that simply won't work, right? If people want to send money, they can't spend more, or they can't battle each other in fees to send that money. That just doesn't make any sense. So Move was really taken into account. One, it needs to move coins consistently and for cheap, and it needs to scale to very high throughput if it's going to be inserted into all of Meta's products. Now, there's a couple things that make it really different. One is this resource-oriented programming. So many widely used programming languages are object-oriented. Move is different in that it's resource-oriented. That includes built-in type first-class resources for digital assets. You can think of Move as much more Lego block. A lot of the actions and the functions are already predefined. So in a way that you might compile this in Ethereum, you could conceivably write this into code in a way that has an exploit. That's one of the big advantages to the Move ecosystem, both in Sui and in Aptos, is that if you want to build with it, it's just a little bit easier to build with, and the exploit risk is dropped tremendously. So there's not as strong of a need for an audit. It's basically built de-risking a lot of what Ethereum's already done. Again, there's things like formal verification. So it offers built-in support for the verification and the correctness of the code, right? No need for that external audit. Limited mutability, which means less variables, less room for adjustments on the code level. This is where a lot of the security comes from, right? They basically locked in elements that they can say these are safe if they're used in this way, and there's no way to alter that. And parallel transaction support. So most blockchains only support executing transactions sequentially, right, block by block, to avoid potential conflicts. Move's resource-centric model enables parallelization, since it's easy to determine if two transactions interact within the same resource. And parallelization is something that we're seeing happen in Solana. It's happening in some further chains like Monad, which is an EVM chain. I believe Mega ETH also doing it. So you are going to see a lot of EVM chains, Ethereum Virtual Machine assets, doing parallelization. And what that means is that they'll be able to hit this kind of scale, but they'll also be able to work with apps that already exist on Ethereum. And I think there is a big unlock there because there's a lot of TVL, a lot of action. Now, some other key elements are a little bit more technical, but in a nutshell, we can see that Move is supposed to be easier to write with and to build apps on, but a little more difficult for the exploits. And like, quite frankly, the industry deals with exploits far too often. I could absolutely go for something that de-risks us there. Now, this all comes back to this week's release, which is Walrus, a new product by the Sui team. And this is one of the features that I think blockchain truly excels at. And what Walrus is decentralized data storage. We've had this very early on since the ICO days with Chia Network, where anyone could run a hard drive. And instead of securing the network through a validator running code, you're basically providing storage space. And that is the way that one would earn tokens. So if you set up hard drives and people begin to store assets on that, you can store a little bit of each asset across many hard drives. This is like RAID redundancy in a single hard drive. So when you're doing like big video files or things that you really want to make sure can't get corrupted, you always have that source file. You might compartmentalize a hard drive so you actually have redundant copies. And that way you can rebuild if something happens. This is the same thing across decentralized storage. You have it redundantly stored, you have it in bits and pieces, and that way if anyone exploits the system, they can't pull out your entire code base or your entire set of information. They only get a little fraction. So again, if that's like a video or an image, they can't recompile the entire thing, right? Now, what makes it really exciting is that it is resilient, it is scalable, it is programmable, and it's secured by a financial asset. Maybe we could take or leave that last part, but this is crypto and we're always going to have a token attached. However, the resiliency, the scalability, and the programmability, I think, are all very interesting use cases and one that blockchain offers very specifically. Now, when I really start to think about why we want this, I mean, we're getting into a place where we're contributing our data and our information just increasingly so to the either to applications or to AI agents. I mean, this is really where it comes down to. And of course we have horror stories out there like 23andMe now going into bankruptcy, storing all of this DNA testing information. I'm in there. I'm not sure what I'm going to do. Am I going to get rid of it? Am I confident that there's not a copy out there? I mean, it already got leaked back in the day, so it's a tough one. But if they had stored this information in a decentralized set, I mean, there could have easily been a corporate structure where they were licensed to access that. But upon bankruptcy, the data could continue to live in a way that doesn't really threaten the release of everyone's info. Now, of course, in corporate structure, I mean, you want to own your own information. That's what their product is built off of. So just from like the core, this isn't really going to work for 23andMe. But if they had taken an approach to be decentralized from the get-go, to have a more positive spin on it rather than just like we're going to capture value, you could easily start to build a 23andMe that is a much safer approach for this kind of data set. So as we get to more sensitive data, the decentralized method seems increasingly more valid. And this could be as simple as everything as your texts, your text history. Maybe you should only be able to access that kind of information from the trusted encrypted enclave in your phone or some from biometrics. I think that's something that we're going to increasingly see as the new regime begins to assault free speech. And we are not necessarily so comfortable with people looking at what goes on inside our phones and our conversations because those could have ramifications. Who knows? But that, to me, is one of the core concepts of why we really want to actually distribute and decentralize our data storage. One, it means that it's just more robust. You can really go to sleep at night, being confident that your data will be safe, that it won't be destroyed. I have so many family images and things that were destroyed in floods because they were stored in my uncle's basement. With this, you could really make that anti-fragile. You can take that anti-fragility of blockchain and apply it to storage. Now, one thing that I'm pretty intrigued by is the concept of zero gravity's ERC 7857. This is an Ethereum-based proposal. The ERC is for an Ethereum-based token. And what Zero Gravity is trying to do here is present it around an AI concept. So Zero Gravity is trying to build an operating system for AI components. That is their core thesis. Now, what they're proposing here is an actual token standard that represents what they call intelligent NFTs, INFTs. And the fundamental concept that they're pushing forth is that we have these LLMs, we have these AI agents, right? We're starting to see tokens that have a wallet, and they're basically a chatbot with a wallet. So they can do the marketing, they can do the buying and selling, and they can, attach that buying and selling to some sort of data feed. The LLM can go both ways. Now, the problem with that is that all of the foundational history of this LLM, all of the data that it accrues, basically its entire personality and its historical records, well, those sit in some sort of centralized server. And you can't really move that agent around. But what if you do build this amazing agent? What if it's, let's call it just a brand, right? You build a digital agent that sells shoes. It can facilitate the shipping, but all of the finances happen on chain. Well, what if you do build this whole thing as a full-blown brand and it leads the charge, but one day you want to sell it? Like, what do? Do you move everything on the servers? This is an onerous task. And they're saying, well, what if we could wrap the entire thing in a token? So what if this new standard, this INFT, ERC 7857, made it so that you could simply through, let's say, a DEX or even a wallet-to-wallet send, let's reduce it to peer-to-peer, what if you could just send the entire agent, the digital soul itself? And that includes the LLM program, the prompt scripts, all of the historical records. So for something like that, you're going to need storage. And of course, Zero Gravity has their own zero-G storage. Of course, data availability space, which is going to call past history on what that has actually interacted with in a blockchain way, and a services marketplace. You can see that the idea is coming to fruition, that we could essentially build these autonomous beings and we could store them all in a single token. So I could trade them just like I could trade any other asset. However, it allows you to grow them, to scale them, to build them into real businesses, and then of course sell them with a simple blockchain transaction. I think that's pretty cool. Obviously, Zero Gravity is using their own storage, not Walrus, so there is competition out there. But considering that this is one of the better use cases for blockchain, I'm all for competition here. Now, to sum this up, I did find this great post, and this is really what we have to ask, right? Is decentralized storage cheaper than centralized storage by around 78% on average? Let me see. And this Denzi Deng did a great job just kind of collating and comparing some of the offerings. We have Arweave, another 2017 ICO startup, Filecoin also around that same time, ETH Storage. Frankly, I'm not as familiar with them. And then, of course, Walrus Protocol. Now, Arweave, they call it the perma web. They wanted to build a web that was permanent in that sense, using decentralized storage as the foundation that everything would be there forever. However, their structure kind of falls into US securities law. It allows you to create these applications that share revenue, and quite frankly, it's a bit tough because it does become a security. It's a third party returning revenue, and it kind of meets the three prongs of the Howey test. However, you can see $7 a gigabyte one time, right? Once you pay an Arweave, you're in there for a minimum of 200 years. So pretty great, right? You have massive redundancy. You can have 20 replicas, right? So the replicas is just the redundancy of what you're doing. Now, we can see those prices do vary. Walrus is coming out with a per month at 25 cents a gigabyte per month, and they're subsidizing it with their capital raise. This is venture backed by A16Z. With a storage duration, now this has a max of 2 years versus a min of 200 years. You really do have to ask yourself, what kind of storage are you looking for? Maybe if I want to store files that I would love the future to hold, Arweave could be the way to go. Even Filecoin has this minimum of 25 years, whereas ETH storage is going for indefinite. And the replicas matter, but I don't know how important that is to me right now. However, we can see that Walrus is coming out and saying, hey, maybe you're not looking to build the perma web on this. Maybe you're looking to build applications that access decentralized storage, and they are looking pretty darn cheap in comparison to others. And of course, we go on to share some more charts. And I think if you're really curious, I'm just going to let you dive in because the data is here. I don't think you need me to repeat it for you. But this is a good breakdown, and we can see it is a fairly competitive space. But that being said, when people ask, well, what is blockchain good for? I would say decentralized data storage is an excellent solution to that. As of now, so much of the world is functioning on Amazon Web Services. And of course, if you're a business and you're pushing out things that aren't desired, they can shut you down. That is in the terms and services. So if you're looking for a more permanent way to deal with information, with data, things that are extremely sensitive, like genetic data, I find, would be great fits for decentralized storage. It really fits those bills. But hopefully we can add components with decentralized storage being at the base, and we can start to build the Internet of Truth. I think Arweave did a great concept calling it the permaweb. But if we want to understand truth and how information is entering the public sphere, it will be worthwhile to have records of when it did enter the digital sphere and from whom it entered, right? Who put that in place? Maybe then we can go back and say, hey, your reputation is at risk for spreading this misinformation. This is how we start to dig ourselves out of this truthless era or this post-truth era of just truthiness. I do think blockchain is the mechanism that provides that foundation of truth and security, which is why it's able to facilitate money. But all of this is continuing to grow and scale. Sui and Walrus is a much faster, much bigger version that we've seen of decentralized storage. And, competition is on now. So best luck to all of them. And with that being said, signing off, go touch some grass this weekend. Have yourself a great time. Ignore the market prices because it's probably going to be painful for a while. Maybe when it gets really, really painful, buy a little more. But until then, save your cash for something good. And as always, good luck, and I'll see you on Monday.